No, really, really delighted.
Really excited to talk about your book, Lifetime. It's going great, isn't it?
It is extraordinary. I mean, I got a note from the publisher saying it's #2 in hardback sales,
Right.
and the fact that it's actually reaching people.
People are reading it.
It's reading it. Well, at least they're buying it.
So we're just going to ask a few questions about the book. If you could give a brief description of the body clock and its importance in our daily life, what would you say?
So it really is extraordinary. We have not only humans, but almost all life on Earth, an internal biological representation of the day, a biological clock, a circadian clock, which is a subcellular process. So it's genes producing proteins forming a complex and going in, turning off the expression of our own genes, those protein complexes then degrading, and the whole sort of system. So you've got this wonderful molecular oscillation, and that's at the heart of these circadian rhythms. And there's a master clock in the brain, in the suprachiasmatic nuclei, deep in the hypothalamus. And we thought essentially in the old days that this master clock would force rhythmicity on every aspect of our physiology, with its hormone release, with its behavior, you name it. And now we know that every cell in the body has its capacity to produce its own circadian rhythm. So it's like this, like this conductor of an orchestra producing a rhythmic temporal beat from which all the component parts of the body, the members of the orchestra, take a reference cue and align their biology accordingly. So what you've got is this temporal, this time network, which is used to regulate every aspect of our biology. So our metabolism whilst we sleep is the mobilization of calories to generate energy so that we survive overnight. Whereas during the day it's a different sort of metabolism. We're taking in calories which we then burn, and that drives our metabolism. Our immune system is turned up during the day when we're likely to encounter other pathogens, other people with pathogens, but it's turned down at night. So everything is gated by the clock, and that has extraordinary implications. So antihypertensives, if you take them before you go to bed rather than first thing in the morning, it can halve your chances of having a stroke.
So Russell, can you describe the difference between sleepiness and actual fatigue?
Sleepiness is cured by sleep. Fatigue is usually this overwhelming tiredness and lethargy, and it's indicative of an underlying health problem. One really important point, though, is that sleep is like shoe size. One size does not fit all. And so you see papers coming out saying, oh, you must get 8 hours, or you must get 7 hours. Well, that's just nonsense. What you have to do is work out how much sleep that each of us needs individually for our optimum performance. And if you're performing at a high level during the day at the level you want to perform, you're probably getting the sleep you need at night. From diary records and just writings from the pre-industrial era, people have deduced that human sleep wasn't this single consolidated block, but was what's called biphasic, which means you go to sleep, you wake up for a bit, and then you go back to sleep.
I read about this. In the Middle Ages, they discovered that there was a split.
And it can even be polyphasic, which means that humans are just like every other mammal. We don't have, we naturally, we don't normally have this consolidated block. And what's happened is our sleep has been squeezed into a relatively narrow window. But there's also an element of supreme human arrogance. We just assume we can do whatever we like at whatever time of day. And we sort of feel that we can conquer everything. And we are above our grubby world of biology. And because cheap electric light enabled us to invade the night, we did it. And in the process, we threw away one of those essential bits of our biology. And we're now beginning to understand once more what sleep provides us. I guess there's 3 reasons why people may be experiencing disrupted poorer sleep as a result of COVID. So you've got the fatigue aspect, you've got the economic aspect bleeding into increased levels of stress. But there's a third area which I think is really interesting, in that the duration of sleep, because you haven't sort of got to get up for the commute and you're getting your shirt and tie on and all the rest of it for the day at work, our duration of sleep is expanded, which means we're more likely to experience biphasic or polyphasic sleep. And so what's been happening, I think, is that people have been waking up thinking, oh my God, I'm never going to get back to sleep.
Yeah.
And actually interpreting this more natural pattern of sleep, this expanded biphasic or polyphasic sleep, as worse sleep, because they don't know that waking up in the middle of the night and then going back to sleep again is the natural state.
It's actually okay.
It's okay. Yeah.
So, Russell, we've talked extensively, you and I, about sort of focusing on the young researchers, and you're one of the founding investigators here at the Kavli, and so important. So it's pretty much one of the purposes that we really want to move forward. So, as I was reading your book, I thought it was interesting. You talk a lot about your journey so far. You know, just these great stories, kind of like rattle throughout the science and just
the greasy sausage one.
Yes, the greasy sausage story, and just stuck in elevators with people, and just, you know. And I feel like that's a gift you gave in those stories. But tell me, what is it that you mostly want a junior researcher to take away from your book?
I guess the advice I will give, as long as the data are absolutely the best data you can generate, keep on kicking the doors until the buggers let you in, and try not to be deflective.
Yeah. How do you think being at the Kavli is going to affect your research, or has it already affected your research?
All of the exciting new scientific discoveries seem to be at the interface between different disciplines. Yeah. That's what we've got in this building. We've got lots of people working in different areas, and we're already beginning to see starts of collaboration. So Kara Robinson, our team, are thinking about, well, how can we learn more about the signaling pathways of these light detecting systems that are regulating the clock? There are huge unknowns. I mean, massive questions that we don't know, and we're not capable of answering of ourselves. But we will by collaborating with other members of the institute. So I think that's one really important area, and I think we'll look back on this time and realise, my goodness, what a brilliant idea that should be. Yeah. I mean, clearly, you know, a lot of the power in Oxford is within the departments, and so de-siloing and actually blurring the boundaries is not trivial. No. But this is the crucible whereby it's happening in Oxford.
So the final question is, will you sign my book, please?